Today we will see about what is a view and how to create a view in SQL. For that, you need to know the three schema architecture. This is a three schema architecture, you all know. It consists of three levels of abstraction. The lowest level is the internal level, where it deals with the physical schema, and is the middle one, the conceptual or the logical level, where the actual database schema resides, and on the external level where we provide the view. Okay, so that view may not be the actual database, it is the view that we are providing to the, or it is the abstraction of data that we are providing to the users. So who are the actual users that are dealing with or interacting with these different levels? The physical schema is actually accessed by the system programmers, and the logical schema is by the database designers, and the other database users are only accessing the external level where the views are provided. There, each database user groups have been provided with different views. That means each user group is having different user views or different views of the logical schema. That means the actual logical schema is not visible to the database user. They are getting only another view of that data. Maybe the tables are different, maybe the table names are different, maybe all data are not visible to them. Lot of difference will be, the view will be different for each user groups. This is what actually telling here. We have a user one, group 1 and user group 2, user group 3. Maybe we can say an example like for an university database, the user 1 or the user group 1 is actually a student group. For each student, all the data inside the database or university database which resides in the conceptual level are not visible to all the student groups. They can view only a part of data, maybe their profiles or their own marks are visible to them. Likewise, to teachers, they may get some other view of the whole class. They can view the whole, marks of whole class, the details of whole class they are teaching, or they may be a advisor for some batches and they can view all the subject details of that batch. Likewise, their view is different. Maybe for the university staff, they may be for university staff, among the university staff itself, maybe some are responsible for the data entry and other verifications are there. Some other staffs are also there. So both their views may be different. Likewise, there may be lot of user groups are there. For each user groups, their view is different. So the actual database or the logical schema is not visible to the entire users. Each user group is provided with different views. So for each user groups, we are providing a virtual database or virtual table. That means in the conceptual level, there is a logical schema which consists of 10 or 12 tables, and each table contains 4 or 5 or 6 columns, that means attributes, and all these things are not visible to each user groups. So for an user, if you want to provide only data from 2 different tables and only if 2 or 3 columns from each tables need to be visible for them, then we can provide a single view combining both tables, or 2 different views from 2 different tables can be created, and these views will act as a temporary table. That means that is actually for a database user, it is the actual table they access the database. For them, it is the actual table, but it is actually a virtual table that are made visible to them. Okay, so these views are actually a virtual table which are visible to the database user. They may be or may not be exist in the database. That means if there is a table like student in database and the student is visible to the database user, then that table is actually residing in table also, in the logical schema also. So sometimes it may be the table visible to the user may be a part of that. Then it is a virtual table because what they view is not the actual table. Maybe even the name of the table may be different. The name of the table will be the view name that we are given at the time of creation. Okay, so a view is actually a virtual table or a virtual relation which does not necessarily exist in the database, and this table will be produced only upon request. That means when a user groups click some user application, then you can say an example, a student login into the KTU platform, university platform, and click on some button or link to view their mark sheet. Then only the view corresponding to the mark sheet will be produced. So what is actually this view? This view is nothing more than an SQL statement. That means this view is created only when an user requests for that, and so this view doesn't exist in the database. It is only produced at the time of request. So view is nothing but an SQL statement. We'll explain you with an example, or before that we will see the syntax how to create a view. If you want to create a view, the syntax is, we can do it using create view command. You can use the command as create view, a view name as an SQL query. This is the syntax for creating a view. That means a result of the SQL query will be a select query is there. The select query will be a relation, a result relation, and that relation is given a name at a view name, and this relation will be the view for the user, and that relation or that table, result table, is available to the user with the name view name. Example, if we using a create table command, we create a table course, then a table will be created at that time, and that will be available at the conceptual level. When we create a view like this, that means select course ID title from course where department name like CSE. A course is a table that is already available in the database. In the conceptual level, it is available as a table. But this select query creates a result set from course table, and it is named as view v1, and this will be available at external level as a table v1. Table v1 consists of two attributes, course ID and title, but it does not contain all the rows. It contains course ID and title of only the CSE department. That is the result set of the SQL, the select query, and that is available as a table v1 for the user. For any user group, it is assigned. So it is available in the external level where the result set is not actually calculated. We say v1 means this select query. The result of this select query is v1. So the select query along with the view name is saved. Nothing else is created or saved. So the v1 view is created only, or this result set or the result for the SQL query or the select query corresponding to view v1 will be created only when any user from user group 1 requests for that any data from that v1. That means some student requests for what are the courses available for the semester, like that. Some application have been developed and he clicks some button or link from that. Then only they need to know what are the courses available. Only at that time the query will be executed and the result will be produced. So in their student application, the select query working will be select title from v1. Okay, so actually from their console they will need to write the query like select title from v1, or in their need to write the select query like this in their application. Only the table name specified will be the view name. That means they need to select the titles from the view v1 that is provided to them. So v1 is the for them v1 is the table in the database from where they can get the title. The actual database tables are not available to them. So they write the query as select title from v1. At that time the v1 will get, when the database execute the query, the v1 will be changed as an alias. As a rename operation, it will work as a rename operation, and the select query will replace at v1. Select title from, it is a nested query, becomes a nested query, and the result set is renamed as v1, and the query will get executed and the output will be produced for the user. This is what actually happens. So when you're creating a view, we can say some properties for the views, like the view can contain all rows of a table, or it contains only selected table rows from a table. What does it depends? It depends only on the select query that we have written for that view. As the view is always depend on the select query, the view can be from a single table or it can be from multiple tables. We can write SQL queries that can get information from more than one tables. We can specify using that in the from clause. So the view can be created from a single table as well as from multiple tables. It's an example of creating a view, the whole view as a whole table from database as a view. Here it uses a select query, select star from course. That means the entire course table is available as view v1. In another example here, the two examples are given. Here only entire table is available, but only course ID and title is available in the first query. Select course ID and title from course. That means all the rows are available, but only the course ID and title columns are available for the user, or it is available in the view v1. In the third example, only the course ID and title of CSE department is available as view v1. That means the number of columns as well as number of rows are reduced. The entire course table is not available, but only a selected attributes for selected columns. Selected columns and selected rows are available as view v1. So that means when you are creating a view, there is nothing in the query. It's just create view name as, then a select query, and the select query decides what data is going to be in the view. So when there is a question for creating some view for some thing, then that something means that is a question, and that question you need to solve it using a select query, and you can use the create view command along with that select query to create that view. That is simple. Only thing is you need to write the select query for that. That is the question that will be the question in this. That will be your task in the question. Here is an example for creating a view from multiple table. That means there is no other difference. Create view v3 as then a SQL query is written, and in that SQL query in the from clause there are two tables mentioned. So the data from two different tables are available in the view v3. This is just an example query. It may not be the right one to may not be a right one, because there is nothing. It's just a Cartesian product is done, no joining is done, so no condition is mentioned, so the result set will be different. It's just an example to show that we can use multiple tables in the from clause and create a view from multiple tables. Another thing comes is, or the another property we can say about view is, a view is a temporary or the virtual relation. So whether the data the user view from that or user get from that view is up to date or not, it will always be up to date. It's always up to date, because every time when a user requests for the data, the query is again evaluated with the current data in the database. So it is re-evaluated every time, so that the data will be up to date for the user. So the next thing is how to delete a view. Delete a view is similar to deleting a table. Here there is no foreign key constraints, nothing like that. We can just use the drop view command to delete a view. We want to delete a view v1, we can write the drop view command as drop view v1. It is simple. It's nothing on the drop command, nothing else on the drop command. It's just we need to delete it, we can use the drop view command. Foreign key and other constraints will not be a problem. Another thing is view modification. That means a user group may be provided with some other permissions, like the student, may not be the case with student. When you consider teachers group, teacher may need to enter new marks to the table. So their view contains student list, student marks, etc., where the teacher can enter new marks also. So an insert permission is also granted to that user. Maybe the user is provided with update options also. They can change the marks or something like that. Some datas. They are provided with update options. They may be provided with delete options as well. So maybe granted with delete operation. So insert, update and delete means we are changing the data in the database. But the user is actually viewing or accessing the view. They are getting the data from the view we are created for them. Then how will they manipulate the data in the actual database? What happens is, the user group for the user group, they will be using some database application where they are using some button clicks or text boxes like entry. Inside the application, they will be written some SQL query for inserting into the view. Means if we are v1 is the view, insert into v1 values, we can provide in the values in that. That means they can consider the view itself as the real table, and they can write the insert query, update query and delete query. Okay. They need to do only in the normal way a user do insert, update and delete operation. There for them the value will be, or the table will be the views. But inside the database, the query they have done or the data they updated or inserted has to be reflected in the actual database. For that, the database designer or administrator will write an instead of trigger for such operations. Before they are granting such operations to the user, they will write an instead of trigger in the database. It will be stored in the logical schema. Okay, as a metadata, it will be stored, and instead of trigger will be stored. Whenever there is an execution of query or insert query or update query or delete query comes on view, and instead of trigger return for the such an operation will get fired, and instead of the query they have written or instead of the query in the application, this trigger will fire a new insert or update or delete operation, which will insert or update or delete data directly into the logical schema. That means the SQL query or the insert or update query which are written by the user is not getting executed. Instead of that, a new SQL query is getting executed. For each operation, for insert on a particular table, update of particular column in a particular table, delete of particular value or particular row in a table, for each table, for each user, for each operation, instead of triggers are written. Okay, for all those operations, whenever such an operation comes, an instead of trigger will get fired, and instead of that query, another query will get executed, and that data will be inserted into the table. Example, if we do an update operation on v1, we like to change the title of some particular course ID, CS30. Oh, there's a mistake in this. In the above query I have written 302, and in the below I have written 308. Both are same actually. Both needs to be the same. The first one is the query written by the user, where he is trying to update the title of a course ID CS302 into PDD from in the view v1 or the table v1, but there is no table like v1. It's just a virtual table, it's a virtual view. So instead of trigger corresponding to this query will be there in the database, it will get executed. Instead of v1, it is converted to course. Everything else remains the same. This is what the trigger, this is what actually returned the trigger. So the v1 is changed to course and the query is executed. So here instead of 308, it has to be CS302. It means update course, set title equal to PDD, where course ID like CS302. Here it's CS302. It has to be CS302, not 308. Okay. So this is what actually happens when we give permissions to the user for inserting, deleting or updating values in views. They will write queries to update the or insert into the view. It will be changed to the actual database query using a instead of trigger. More about instead of triggers will be explained in the next class. Next one, this one is also an important one. A materialized view. What is a materialized view? Think about a situation where the base tables, the actual tables in the logical schema is not getting changed, or it is not getting changed frequently. It changes only a few times in a year. It changes during only the end of semesters, like that only. So re-executing something based on that base table every time a user request is actually a waste of time, waste of processing. Means the data is not changing every time. They are creating the same result set because the base table remains the same, it is not getting changed. So the solution is we can create a temporary table itself for the view. This is what we call a materialized view. That means because the base table is not changing very frequently, instead of storing the definition of view, that means the select query of the view, we are creating the temporary table for view. That means a temporary view table is created. The result set is stored itself as a temporary table in the external level. So whenever there is a request on the view, that will be satisfied from the temporary table itself. There is no need to calculate or access the original database every time when there is a request. That means in a materialized view, the view is actually available as a temporary table. Okay, that table is not a permanent table, it's a temporary table. Whenever the data changes in the actual database, in the logical schema or in the actual database, this is invalid. We need to recalculate it. So how will you do the updation in the materialized view? We can use different strategies for automatically updating the view table or temporary view. We can automatically update the view table using some other some strategies. We can, whenever a base table changes or whenever the base table is getting updated, we can delete the materialized view and create the view again, or we can create the next temporary table when another request comes for that view. That means whenever the view is updated or whenever the base table is updated, we will delete the materialized temporary table. We will delete the temporary table, and only upon the next request the query will be executed and a new temporary table will be created. We can do like that, or we can rematerialize the view as another strategy. That means whenever the base table changes, we will again run the select query of the view and create another temporary table. That means we rematerialize the view. The same thing before the request itself. The first method is that temporary table is deleted and the new table is created only, new temporary table is created only when another request for that table comes. Second method is deleting the materialized view and creating another temporary view or another temporary table at that time itself. It does not wait for another request from the user. The third one is incrementally updating the view. Whatever data is being updated in the logical table is updated in the temporary table also. That updation is actually incrementally updated in the view. That means if something title is changed for a particular course, then only that value is updated in the view, or only that value is updated in the temporary table. We doesn't need to change the entire table, or we doesn't need to process the entire select query again. We just need to cascade the update to the temporary table also. So these are the different strategies we use to update the materialized view. We can adopt any method of the three. This is about views. Okay, now we'll see two examples. First question, creates create a view so that a manager at branch B003 can only see details for staff who work in his or her office. We are given with a staff table. Here we need to create a view for the manager so that he can view only details of his staff. That means we need to write a select query such that the result of that select query is the details of staff in the branch B003. And creating such a view can be done using the syntax of create view. That means create view a view name as then a select query. Here I have given the view name as manager to staff. So create view manager to staff as, what is the select query needed here? It is the select star from staff where branch like B003. Okay, so it will select, the select query will select details of all the staffs where the branch name is like B003. That means the branch, all the details of all the staff working in branch B003 will be created as a result set and it will be available as a view. So this is the answer for this question. Second question, creating a view for department details where we need to include department name, building and the number of courses in that department, and we have provided with two tables, department and course. Department contains the department name, building and budget, and course name contains the course ID, title and department name and its credits. So we need to combine these two tables and need to select two things from department table, and we need to count the course ID from course. So how will you write the select query, or how will you create the view? We can create a view as create view department details as a select query. In that select query we use group by clause to group each department and use a count star to count the number of courses in that. So the select query is like select department name, building and count star from department D, course C, where department name equal to D dot department name equal to C dot department name, a group by D dot department name. You can also write D dot department name comma building, otherwise it may cause some error. We need to mention all other attributes in the group by clause when you are using aggregate function and group by. So in the group by clause we need to include D dot department name comma building. Okay, so it will be created as a result set, and this result set will be available as a view department details. Here I have written some other things along with the view name. In parentheses I have written three names, and these three names will be available as the attribute name in the view. Okay, if we want to provide new names for the attributes in the view, along with the view name we can provide the attribute name also. Okay, like this. So create view department details in parentheses department name, building, count, which means that a department details view will be created and its attribute name will be the names specified. Okay, so the questions will be like this only, creating a view, or otherwise the question will be what are views or what is a materials view, like that only. If you have any doubts you can ask me directly or you can comment